Hello, this is Mr. Stansbury. I'm going to take you through some of the problems on the 7E Part 1 assignment. First one we're going to take a look at is number 1 here. A flagpole casts a shadow of 9.32 meters. So let's just draw that. So here's our flag. And then let's say the sun is up here. And it's casting a shadow of 9.32 meters. So we'll say that this is 9.32 meters. Hopefully the flagpole is perfectly straight up and down. Now it says when the angle of elevation to the sun is 63 degrees. So the angle of elevation would be this one, this angle of elevation. So if you hold your hand straight out and you go up, it's going to go up 63 degrees. So as you can tell, my drawing here is not to scale because that would mean it would be over here, but that's all right because we're just getting this so that we can set stuff up. Find the height of the flagpole. So that's what we're looking for. So from this angle, that's the hypotenuse. This is the opposite. And this is the adjacent. So to figure out this height here, we're going to need to use tangent, right? Because adjacent and opposite is tangent. So tangent 63 is going to equal h over 9.32. So multiply both sides by 9.32. And that should tell us what the height of that thing is, height of the flagpole. So 9.32 tangent 63 gives us that it's about 18.3 meters high. Okay, so that's what that height of that flagpole should be. Okay, next one to take a look at, number 2, a steep hill is inclined at 18% to the horizontal. So let's just draw that right off the bat. So here's horizontal, and then here's our steep hill, and they're saying that this is 18 degrees to the horizontal. Okay, I know that doesn't look like it's terribly steep, but if you're walking up it, that's a pretty steep hill. It runs down to the beach, so its base is at sea level. Okay, so we've got this here. So we're going to come down to the beach, and the beach is at sea level here. If I walk 150 meters up the hill, what is my height above sea level? So if I walk 150 meters up the hill, so this should be 150 meters here, what is my height above sea level? So there's our angle. That's the opposite. That's the hypotenuse. So that's going to be sine, right? So should be sine 18 equals the opposite, which is the height here, over the hypotenuse, which is 150. Multiply both sides by 150, and that should be able to help us figure out the height. So we do 150 sine 18, and we get 46.4. So should be 46.4 meters above sea level. Okay, we're going to just take a quick look at how to set up number 4, but not go all the way through to finish this thing off. It says a train must climb a constant gradient of 5.5 meters for every 200 meters of track. Find the angle of incline. So we've got this triangle here, right? And we got to figure out what is what on this triangle. So here's our right angle. A train must climb a constant gradient of 5.5 meters for every 200 meters of track. Okay, so here's what I want you to think of. 200 meters of track. The track is going to go along this horizontal piece right here. So that's our track. So we want to put 200 meters here, and then the constant gradient of 5.5 meters, that's how far up we're going. That's going to be right here, 5.5 meters. Okay, so that's our setup for this. So this is going to be our angle of incline right there. Okay, so that's how you set up number 4. Okay, let's take a look at another one here. 5. Find the angle of elevation to the top of a 56 meter high building from point A, which is 113 meters from the base. So they already do the picture. We got to figure out what that angle there is. So this, here's our hypotenuse. This is the opposite, and this is the adjacent. So opposite and adjacent is tangent. So we would do tan theta equals opposite, which is 56, over adjacent, which is 113. And since we are looking for an angle, this is where we're going to want to do second tangent. So second tangent of 56 divided by 113 gives us 26.4 degrees. Now, part B says, what is the angle of depression from the top of the building to A? So here's how you'd want to figure out angle of depression. So it's always from horizontal, and if it's angle of depression, it's how far down. So it's basically saying, what is this angle right in here? Guess what? These lines here are parallel because they're both horizontal, and these are alternate interior angles. So guess what? The angle of depression is the same as the angle of elevation. Angle of elevation, angle of depression, it's going to be the same. So that's also going to be 26.4 degrees. Okay. Okay. Number 7, find theta, the pitch of the roof. So the pitch of the roof is basically its rise over its run, which will be the same as this angle here. So what we're going to want to do, since this is an isosceles triangle, we can drop this straight down, and that cuts this from here to here exactly in half. So we know that this part here is 15, so half of 15 is 7.5, and this is still 0.6 because that didn't get cut in half at all. And that's 8.3. So if we're going to draw this thing, I'm going to draw it a little bigger so we can see our numbers a little bit better. We're looking for this angle here. This is 8.3 meters, and then this right here is going to be 7.5 plus 0.6. which is going to give us 8.1. Okay, so to figure out what our angle here is, let's see, this is the hypotenuse. This is the adjacent, so that's going to be, hypotenuse and adjacent is cosine. Cosine theta equals adjacent, which is 8.1, over hypotenuse, which is 8.3. So since we are looking for an angle, we're going to do second cosine of 8.1 divided by 8.3. And that gives us an angle of 12.6 degrees. Okay? Okay. And then last one for 7E part 1 is 9. A rectangular field is 20 meters longer than it is wide. So let's say if this is our width, this is going to be the width plus 20. When Patrick walks from one corner to the opposite corner along this, say, diagonal line here, with the shorter, he makes an angle with 55 degrees with the shorter side of the field. So this angle right here is 55 degrees. Find the length of this shorter side. So we're trying to figure out what this short side here is. So let's see what we can figure out. Well, let's just treat it like we normally would. So this side over here is the opposite side. This side here is the adjacent side. So the opposite adjacent is tangent. So let's try this. Tangent of 55 should equal opposite, which is W plus 20, over adjacent, which is W. Now we can figure out what tangent 55 equals. So let's do that. Tangent 55 gives us 1.43, we'll call it. Or maybe 1.428. We'll give it a little bit more for 1.428 equals W plus 20 over W. Okay? So now what we could do is put this over 1 and then do cross products, right? So 1.428 times W is 1.428 W. And that's going to equal 1 times W plus 20. 1 of W plus 20 is simply W plus 20, right? So we've got the W, we got W on both sides and then only a 20 on the right side. So I'm going to subtract a W here. So that's really subtracting 1 W, right? Because these are ones. So we know that 20 is going to equal 0.428 W's. So we can divide both sides by 0.428. And that should tell us what our W equals. So 20 divided by 0.428 gives us about 46.7. 0.7, and this is in meters. Okay? All right. That's all we have for the first half of the 7E assignment. If you have any further questions on this or anything else, please feel free to ask. Thanks.